Oh, the music is off. What's up, people? Welcome to chapter 3. So it's the first lesson of chapter 3. We're talking about graphing a line, but it's going to have a ton of curves in the middle. And the arrows could be going up, the arrows could be going down, but it's going to be like a really high exponent, like x to the 4th power, x to the 6th power, just not x squared and not x to the 1st. So it's called a polynomial. And my learning goal is going to be to identify the characteristics of a polynomial graph. Like, which way does it head? Up, down? Is it negative? Is it positive? Stuff like that. Okay? So, leading coefficient refers to the non-zero number, like 3x to the 3rd. The 3 is the coefficient. I probably shouldn't do double 3s. That'll confuse people. So 3 is the 3x to the 5th. The 3 is the coefficient. Or negative 17m squared. The negative 17 is the coefficient. So it's the non-zero number that is multiplied by the largest power of x. All we care about is what's the largest power of x. I don't really care what's in the middle. This could be the super long polynomial, but all I care about is what's in front. That's huge. And I do care about what's at the end, like the last number, the constant. Degree of the polynomial. The degree, we did that for bell work, is the largest degree of any of the terms, wherever it is. You might have to reorder it. Okay. Terms of the polynomial. Of parts in a polynomial. The separation, and that's going to be like plus or minus sign, plus sign, minus sign, of parts in a polynomial function. So like for bell work, I gave you this problem. Negative 5x to the 5th plus 2x to the 3rd plus 7x minus 3. That has 4 terms. Negative 5 is the leading coefficient. And it's to the 5th degree. So we need to be able to identify these characteristics. Positive, negative, odd, even. Okay. Last one. Standard form of a polynomial shows any I don't know. I'm just not going to do that one right now. Okay. Standard form is going to be like the biggest exponent first. So I'll just put that largest exponent first. That's all I care about. And then you order the rest in descending order. So the 5th degree would be like 5th degree, then 4th degree, then 3rd, then squared, then 1st degree, then constant. So I just want the biggest exponent in front, and then the rest in order going downward. All right, we're doing, how can you write a polynomial in standard form and use it to identify, okay, well, here's what I need. What's the leading coefficient? LC. I'm going to move up the paper. What's the degree? I'm going to just write this to help you stay organized. Dag number terms. Yeah, if it's not in order, fix it. You've got to, yeah. Okay. Here we go. Here's the proper order. Keep the signs. Be so careful. 2x to the third comes first. What comes next after that?
4x.
Negative 4x. And then the plus 9. So from here, I'm looking at what's the leading coefficient, what's the degree, because it's the things in front is the most important. It's like the head honcho, the VIP. So my leading coefficient is going to be 2. My degree is going to be the third. And then how many terms are there? 3 terms.
Trinomial.
It would be called a trinomial. So right. Right you are. So this I'm practicing just rewriting it because I can't even graph it in Desmos unless it's in order. I mean, Desmos actually is way smarter than that, so I can't say that, but anytime you do a graph, it needs to be in order. You can't go out of order. It's too confusing for students. Okay. Rewrite B. What's going to come first, people? You are so right. What comes after that?
3x.
Good, and you'll just put a plus sign in between because it's a positive 3. And then my constant is the negative 1. The number all alone. Remember how we would call that the y-intercept? It's still the y-intercept. All right, leading coefficient, 3. Degree, second. Number of terms, 3 again. Okay, do C on your own. Reorder it. Ooh, that's got a lot of terms. Do C on your own.
That was kind of easy.
Is easy? Good. This is easy because this is stuff that you've seen before. Oh, 2x to the 6th plus x to the 5th. Tell me the rest out loud. Then minus 8x. Okay. Wow. This has a lot of terms, guys. 1, 2, 3, 4, 5. The degree is the what degree? 6th. And my leading coefficient is? 2. Circling it's good. Seem fine? Doable?
What's the homework?
We'll get there when I'm done. This is exactly what I already did on the board. Some of you are going to need the screen pulled up, right? It's my arms. What's happening? End behavior. What's the arrow going towards? Where's the arrow pointing? So, it's just this on the board, but I am going to rewrite it here because you need it on paper. You know? The board's fine, but when you walk out of the room, you won't have it anymore. So, odd degree, odd positive. Here we go. It's going to look like, I don't care how many wiggles you put in the middle. Doesn't matter to me, guys. But odd positive is going to go in an upward. Let me get my ruler so you can remember. Like upward, right? So it starts down here, and you can do zigzags to your heart's content as long as it's going down left and up right. Because it looks odd. Ooh, that's so hard to see, huh, guys?
I put
Sorry. I need you to see this board. I have no choice. Oh, how about all the way up? All the way up. All the way up.
No one can stop me. I'm all the way up.
Okay. I'm also a rapper and a gangster.
Bruh, Miss Granny's not about the thug life.
Yeah. All right.
How much detonated wham?
So, odd degree. The end behavior is going to be the same as a line that's just going like up. You can do as many curves and turns in the middle. So here we go. Odd positive. As x goes to positive infinity, y, f of x, if it's going upright, if x goes to the right, and look, it is. My arrow is going to the right and it's going up. So f of x, y, is going to go up, positive infinity. Right up. Okay?
Wait, f of x is just like another way of saying y, right?
F of x is the same as y.
Oh, okay. I keep saying it in my head, but I don't know if it's true.
It's true. Odd, negative. Negative leading coefficient. It would look similar to this straight line. Like that. So, I have to talk about the end behavior and I have to draw it. Odd, negative. Okay, remember how odd I look. I look really odd.
Dude, stop, Miss Grant. It's not nice. Dude.
Okay. So, down, I'll just do one bump. Anyways, that would be a third degree, for example. The exponents are odd, negative 5x to the third, something like that. Now, end behavior. Left. What's happening here? Left what? Up or down?
Up.
Left up. X is going to the right. Y is going up. Left up. X is going to the left. Negative, 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 but it's also going up, 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 up. As x goes to negative infinity, f of x goes to up, positive infinity. I forgot to finish the top one, you guys. I forgot to finish this one.
Yeah, I don't know what to put there.
I need to go back to that because I forgot to finish it. As x is going to the right, y is going up. As x goes to the left, the more left the line goes, the more down it goes. The more left, left, down, left, down. As x goes to negative infinity, left, y, f of x, is going downward.
Salute. Why are you coughing?
It's a snuff. Okay.
Allergies.
Odd, negative. X left,
She's from Buena Park.
Y up. Left up. That's one of the arrows. What's the other arrow doing? Down and down right. Down right. So down right is going to be x is going to the right, but y is going down. X is going to positive infinity. F of x, which is y, is going downward to negative infinity. Right, down. I only heard the beginning of that sentence. You have a strong feeling. A mean war? Moonwalk. Like Michael Jackson?
Yeah.
You're so random. What? Moonwalk?
Miss Grant, you just yelled out of nowhere you're a thug.
Do thugs moonwalk? Is that
No,
like a
but
trait?
like, how is that not random?
Okay. Thanks for sharing. Okay. Even. Let's go even positive.
Buena Park.
That would be like positive 4x to the 6th. Like a positive number as my leading coefficient and an even, or you can't see it, an even exponent. It's going to look like this. Even, guys, same direction. Up, up, down, down. Even. Up, up, x squared, x to the fourth, x to the sixth, x to the eighth. Negative x squared, negative x to the fourth, negative x to the sixth, negative x to the eighth. Down, down, up, up. So something like, I don't know. I could even do just a parabola or tons of wigglies in the middle. Whatever. But the point is that my end behavior is always going to go up for my y's. My y's go up, 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 up. As x goes to the right, positive infinity. Y, f of x, goes where? As x goes to the right, where does y go?
Up.
Up. Also positive infinity. That's up. So I have to look at every arrow. There's two of them. Two arrows. Two end behaviors. As x goes to the left, which is called negative infinity, y goes to the up, positive infinity. Okay? And here's this. Negative even would be like this. I could just do a simple parabola also. How about that? That's a negative x squared. As x goes to the right, y goes down. Negative infinity. As x approaches positive infinity, y approaches negative infinity. That's the verbal way I say it mathematically. As x approaches positive infinity, y approaches negative infinity. Approach. That's the word we use. Approach. And then lastly, we're almost done, guys. X goes to the left. Y, f of x, goes down. You're getting really good at infinities, huh? Okay. Next thing to do, find the end behavior. So I'm either going to give you a graph to look at or I'm going to write an equation. This equation is not too hard because it is a, what's 8? Is 8 positive or negative?
Positive.
Pause. And what's third degree? Odd. Odd positive. So you look here. Odd positive is this. Or you could look up it above higher. It's odd positive, so you write this. This is an answer to number A. As x goes to negative infinity, f of x, and remember there's two end behaviors for every question because there's two arrows. Odd positive. And then as x goes to positive infinity, as x goes to the right, y, odd positive, y goes up. Okay, what's negative 2? Positive or negative? Negative even. Negative even, right here. This one, it's going to look like that. I would use decimals. We're not going to do table of values. It's just too much. So I have to write this end behavior down for that answer. Here's the answer. Even negative. As x goes towards negative infinity, y goes down to negative infinity. And I'll even draw what it looks like. As x goes to positive infinity, y is still going downward. Right down. Right down. Okay, is this all clear? End behavior?
Yes.
Is it making sense that this is a...
Sorry.
This all brand new stuff. I have this long polynomial that I have to graph, but I kind of want to know what it looks like. And so this all tells us what it would approximately look like. So then on the next page, we're actually going to go through. I want to just do only one thing on it for you. Woo, this is a lot. The second page is, yeah. We need to copy down what the parent functions look like so you guys know. This is going to be y equals x. It's going to look like this. Oh, constant. Ay, no. I'm so sorry. Y equals like a number, like 5. Oh, man. Yeah, like y equals 5. Would be something like this.
0 slope.
It has no x. 0 slope. Linear, straight line. This is going to be x to the first degree. So like y equals x to the first degree. That's the diagonal line, like that. Quadratic is what degree?
Second.
Quad, second degree. Okay? Y equals x squared. Just a normal parabola. Cubic. You know, I could do f of x instead of y, yeah? X to the third. It's going to look like this. Odd positive, guys. Odd positive. The bend usually happens around the origin. Just for third degrees, the bend happens at the origin. In the middle there. So these are graphs that you need to have memorized. And it's also like, if I draw a horizontal line, how many times does it touch? 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2. That's how you know what degree it is. Just by you can count all the curves. The last two are on the back page. Quartic, 4. Quartic. Quintic, 5. Quin. Quartic. Y equals x to the fourth. Up. Positive even. Positive even. Ready? With some bends. Only like 2 bends though. Quintic, 5th degree. That would be odd. It looks odd. Because it is, and it has some bends in the middle. Okay. So, because you look at the exponent. The exponent tells you what happens in the middle. So, the rest of this worksheet, all the missing problems are homework. I'm going to stop the video.